This is an early test video for one of the white spikes from 2021's The Tomorrow War. But it's very different from what the viewer sees in the finished movie.
The creatures are not really conducive to having an actor inside.
To get here, Spectral Motion built a moving animatronic powered by motors known as servos, which was used as a reference for the visual effects team and even ended up in some of the final shots. Movement is what really sells any animatronic character in a movie, so roboticists like Mark Setrakian work tirelessly to nail down realistic motions. Like these gigantic troll hands from 2013's Hansel and Gretel Witch Hunters, which needed to move nimbly enough to convincingly pick up objects and throw punches. The performer who played Edward the Troll wore 2 animatronic hands, but they were so large that the performer's hands only reached the troll's wrists. As he moved the hands around, the subtle finger motions were created with radio-controlled hobby servos, like you'd find in a model plane. Each hand had 10 servos spread throughout the fingers.
Each finger actually has 2 degrees of freedom. That means that there's a base knuckle, like this, and then there's these 2 phalanges here that can also move. So you can map each axis of these joysticks to specific joints. In this case, you're mapping them to the finger joints. So depending on how I map those, you can optimize the hand for doing different actions.
Toggling one joystick created a gesture or a point. Running controls simultaneously for the thumb and index fingers, as seen in this early test video, created a pinching motion used to lift up this small object. The work done on top of the servos is equally important. No matter how sophisticated the radio controls, the movements would feel off if each muscle and joint that made up a hand wasn't in exactly the right place. One motion Mark observed in his own hands: compression in this area. The upper palm had to line up perfectly with the knuckles. To achieve this, Mark worked with Spectral Motion sculptors from the start to make sure their model went hand in hand with his servos.
The mechanical design starts with the sculpture. We can see these big wrinkly knuckles. Let's put a little tension on there like it would be in real life. So that joint appears to be right here, and anatomically, that puts it right behind this big fat pad right here. So the anatomy really has to be based on reality, and that's where the best mechanism designs start from.
The ways in which the mechanics and the outer layers work together are even more important when it comes to conveying emotions in the face. That's where soft mechanics come in. These are cables embedded in the outer layer of animatronics. Soft mechanics are often used for animatronics that don't have traditional bones and joints, like the petals on the Demogorgon's head that Mark operated for Stranger Things, or Edward the Troll's tongue. And in 2006's Lady in the Water, Mark and his team wanted to give the wolf-like scrunt an angry snarl. Here are the scrunt's hard mechanics. This piece here both pulls the nose back and lifts it up at the same time. But those hard mechanics had to work hand in hand with the softer elements of the wolf's face, like these lips that pull up and expose the fangs.
And it looks a little odd here without the skin on, but when the skin's on, it looks very realistic.
The skin itself posed a problem, however. Unlike a real wolf, the scrunt had a coat made of grass. So one of the most expressive parts of the face, the eyebrows, weren't coming through that thick layer.
They're like these 2 points, and they move around, and they have whiskers sticking out of them.
So Mark actually strayed from reality and based its eyebrows on human eyebrows.
It was necessary to punch up that expression, that there's no ambiguity about it. When this thing is snarling and it's angry, that those brows are selling that the creature is angry.
When moving down to the scrunt's tail, Mark encountered a very tricky motion challenge: cascading. These complex motions are used for movements like wagging or the curling of a tentacle. So Mark linked up servos in a chain, then created a delay so each servo moved a little bit after the one before it, causing a chain reaction down the piece. The more servos, the smoother the motion. Mark first achieved this effect when building Samael's tentacle mane in 2004's Hellboy. He realized that the cascading quality could be retrofitted to the scrunt's tail. When the delay is set to 0, the tail curls up. Crank up the delay and it wags like a real tail. The Cascade controller also works on fingers. By distributing motion from finger to finger, Mark created the illusion of finger drumming on King Balor's hand from 2008's Hellboy 2. Despite their amazing range, radio-controlled servos have their limits.
So one of the things about robotics that most people don't know is that pound for pound robots have 1/10 the strength of humans or animals.
As you can see here, the Scrunt can look side to side, but it can't tilt its head because they couldn't fit the servos needed in its neck.
Those servos are great, but they're fairly simplistic in the way they're controlled, and they just do one thing. You have to make some decisions about what you're going to leave out.
But fast forward to 2021's The Tomorrow War. This terrifying white spike animatronic that Mark helped create can tilt its head, thanks to major technological advancements. The key here was a modern digital industrial servo. Unlike the large servos used on the Scrunt, Mark says these ones are specifically designed to fit inside of a robot without sacrificing their strength.
This thing is ridiculously strong, so we can put a big, heavy head on the end of this thing, and it can handle it. I can command these with high precision, which has really not been possible prior to then.
This 6-axis module has 6 degrees of freedom.
It can turn, it can tilt, and it can also shift, and it can change length too, which is very unusual.
Like Edward and the Scrunt, the white spike is moved by joysticks. This time, Mark used a software system he built called the Motion Synthesizer.
The functions are represented by little boxes with patch cords connected together. So by connecting the nodes together in patch cords, it's really easy to visualize what's happening from top to bottom.
While the module's tilt motion looks rough at first, once Mark adds filters to it, it becomes smoother and therefore more lifelike. Take some of that filtering off, and it can go much faster.
As I crank this up to around 60, you can see the movement of the puppet component is now becoming very fluid.
No matter how much more powerful the technology gets, the finished product is only as good as the brains behind the operation.
You can always get the puppet working, but you have to get it working at the exact moment it's supposed to be working. Sometimes it doesn't always work out that way, so you gotta adapt.